The benefits of a virtual private network, or VPN, are amazing. I mean, consider having no VPNs. If we had two locations like Site 1 and Site 2, which are connected over the internet, well, if we're sending traffic back and forth and we have sensitive data, anybody with access to this untrusted network who can get copies of those packets can reassemble those packets, and our sensitive confidential information is no longer confidential. So to the rescue, we're going to leverage virtual private networks. And in using virtual private networks, we're going to create a virtual network connection between the two locations. So we're going to use firewall 1 as one end of our VPN gateway and firewall 2 as the other end. And we could refer to these bad boys as VPN peers, because they're acting as the endpoints for that VPN tunnel. Sometimes that tunnel is referred to as a security association. And when we do site-to-site VPN tunnels, we're leveraging IPsec for the encryption and protection of that traffic. So as part of building and designing our VPN infrastructure, we need to define our VPN peers, the endpoints, if you will, for the tunnels. And in Checkpoint, we define the VPN endpoints, or the peers, by using an object called a VPN community. So if we created a VPN community, called it our site-to-site, and then we added firewall 1 and firewall 2 to that community, ta-da! We've just identified the two peers that are going to be communicating. However, we may have more than just two firewalls, two gateways that are going to be part of the same VPN community. Maybe we have 4 sites. Let's call it site A, B, C, and D. And let's also imagine that each of those locations has a single connection over to the internet, and they also have a default route that uses the internet. When we build our VPN tunnels, we could do a full mesh. A full mesh implies that we have connectivity between every location and every other location, meaning VPN tunnels between every site and every other site. And let's not forget B to D here as well. So when every device has a logical VPN tunnel to every other device, that's referred to as a full mesh. So when we create a new VPN community, we can specify it's going to be a mesh, and we can then just identify all the gateways that are going to participate, and they'll know, okay, great, I got to build VPN tunnels to everybody else in the same community because it's a mesh. Another option regarding our VPN communities, which is identifying who's going to peer with each other, is to create a star topology from a VPN perspective. And with a VPN community that's set up as a star, which is also sometimes referred to as hub and spoke, we identify where the hub is going to be. Let's say we have our main site, which is A, and then we're going to build VPN tunnels from A to B, A to C, and A to D. That'd be an example of a hub and spoke or a star community, because B is not pairing with C and C is not pairing with D. And so when we create a new VPN community and we specify that we're going to do a star, it'll simply ask us, okay, who's at the center of your star and who are at the edges? Who are the satellites? And that way Site A knows exactly that it needs to build 3 tunnels respectively, and Site B only has to build a single tunnel up to the hub, up to the center of the star. So VPN communities in Checkpoint are all about who the VPN peers are going to be, who we're going to build VPN tunnels with. Now, another great question when we're building site-to-site VPN tunnels is, whose data are we trying to protect as we send it and receive it over these tunnels? So in our topology, if we wanted to protect the 192.168.1 network and the 10.3.0 network, we could identify those networks, and in a Checkpoint terminology, they refer to the networks that we're trying to protect, who are benefiting from the VPN tunnels. We'd call those networks part of our VPN domain. Now, by default, in a Checkpoint VPN environment, the VPN domain is assumed, and it's a big assumption, but it's assumed that it's going to be everything that's not the external network. Now, on Firewall 1, there's a default route going out E1, and on Firewall 2, there's a default route going out E0. And because of those static default routes, the firewall is assuming that everything that's not using the default route, in this case on Firewall 1, E0 and E2 and those networks, those would be considered internal or inside networks. So it would consider everything except for the external network to be part of the VPN domain. And if we didn't want to accept that, we could go ahead and simply specify in each gateway, okay, this network is part of the VPN domain. On Firewall 2, we could say this network is part of the VPN domain, and that way we can be more granular in identifying our VPN domains, aka the networks that are going to benefit from the tunnels that the gateways are building between them. So with our peers identified through the VPN communities, and we've also identified the networks we want to protect using the concept of the VPN domains, we'd also want to include, as part of our security policy, the specifics of the traffic that we want to permit. So our security policy could say, all traffic from 192.168.1 going to 10.3.0 is going to be associated with a specific VPN community. And as a result, if PC1 sent some traffic over to PC2 or a resource over here at Site 2, Firewall 1 would take that unencrypted traffic, encrypt it, ship it over to Firewall 2, who would then decrypt it and then forward it over to its final destination. And also in our security policy, we'd want to identify the return traffic as well. So we could specify traffic from site 2 going over to site 1. Should also be encrypted. And that way, when this PC responds back, it's plain text here, but the Firewall 2 could encrypt it, ship those packets over the VPN tunnel over to Firewall 1, who would then decrypt the traffic and then forward the unencrypted traffic over to PC 1. And the whole goal is that as traffic crosses over the VPN tunnel, it's both protected and encrypted. So even if somebody does steal copies of our packets that are being sent over the VPN tunnel, they're not going to be able to make sense of it because the data is protected. In this nugget, we've taken a look at a few concepts regarding site-to-site VPNs in a checkpoint environment. I hope this has been informative for you, and I'd like to thank you for viewing.